Okay, well, I'm very, very happy to welcome to the first bio none other than Professor Bruce Jefferson. How are you?
I'm very well, thank you. And how are you, Simon?
Oh, I'm never better, never better. All the better for seeing you, Bruce, I have to say. Just very, very briefly, obviously you've sort of made great waves in research in the last 15 years or so, encompassing MBRs as well as many other things. But how did you first actually get into to wastewater treatment generally?
Okay.
I mean, I assume your parents bought you the Lego wastewater treatment works when you were in your formative years or something.
I wish they had.
Well, certainly for me.
I've always had a fascination with it. I've always known from a very early age that I wanted to be in water. Maybe not sewage, so directly, but water. So I can't remember a time when I didn't think that was the direction I wanted to go in.
What, you mean it from the age of 9 or something, or was
Well,
it
secondary school.
Secondary school onwards. Good grief! How extraordinary.
Whether that was going to be in a university or not would be a later part of the development process, I guess.
Yeah. Was your PhD in water, or was it?
No, yes, in water, in flotation, not
Flotation.
in
Oh, right. Okay, so that's where all that started. Okay, so what are you actually working on now then?
Well, a range of things. The big in the membranes is anaerobic MBRs.
Right.
But a lot on resource recovery, the circular economy.
Oh, right. It's quite big at the moment, isn't it?
Yeah, paradigm shift in wastewater
Oh,
stuff.
the paradigm word. Marvellous.
Yeah, well, you've got to get it in.
You've got to get in paradigm somewhere. I don't see what's wrong with the old paradigms, but everyone seems to like the new paradigms these days. But it's just me, I'm getting old. Okay, so you're doing lots of different research now, mainly working with reuse and, as you say, the circular economy, which is just all about sort of trying to make use of waste generally, I suppose, and sort of redirect it.
But at an all scale, so small works and how can you get the community engaged to add value, all the way up to resource factories, and can we make products and generate energy and water.
Okay, that's quite a big remit. Are you mainly on the energy side, or maybe recycling phosphorus? Or
No, across the board, flow sheet. So we've developed here amongst the team, so Ewan and Anna,
okay.
We've got a flow sheet that we're developing that delivers a resource factory as a sewage works.
Right.
That's a combination of all of those components.
That does sound genuinely interesting, I have to say. We'll have to talk about that later. Okay, so what do you think the best bits of your job at the moment then?
Well, it's always been the same, I guess. It's about working with the students, actually, the research students. I know it's I know it's the glib thing to say, but I actually really do enjoy working with the researchers and actually developing on thinking and discovering stuff. I'm sorry.
No, absolutely. I'm glad you made the distinction between the research students and the taught students, because there probably is a bit of a difference there. But clearly you still do a lot of teaching and...
Yes, less so these days, but yes.
Yeah, okay.
And well, that's fun. We don't do very much here at Cranfield, so it can be enjoyable rather than
I guess it's less mature here. Yeah, I guess that's good. Well, given that you have made sort of this sort of massive impact in your research generally, I mean, you're looking at your record on Scopus and the research publications you've produced, it really is tremendously impressive. So what sort of things in your mind make a good research paper generally, would you say?
I think easy to read. So direct, clear, and with actually some usefulness to it.
Usefulness.
I think you should be able to read a paper and gain something from it.
Right, okay.
And if you can't, then I'm not sure it's a very good research paper. I think the level that it adds doesn't matter so much, just as long as it adds something. Okay. You've contributed. Okay,
you sort of anything recently that you've produced yourself, you sort of think, well, this has definitely added something to the piece, so you're particularly proud of, or you can definitely recognise in yourself that this is perhaps one of your better works. Or...
Yeah, well, I think again, it's probably the team rather than just me, but some of the recent papers we're getting out on the anaerobic MBR that have talked about how to deliver appropriate energy demands and the flux rates you might need to make it practical.
That would be the key, wouldn't it, for anaerobic
and I think, it's a growing field. There's not much out there at the moment, so I think again we're making a real contribution there that hopefully will propel the technology forward a bit.
Well, that would be great, because as I said, there's an awful lot of stuff in anaerobic MBRs in the research literature, but maybe not so much implementation, I would say.
No, I mean, I think the key difference is we keep the solids off the membrane.
Right.
If I summarise very, very, very simply, the key, that you just can't get to a high enough flux, I think, if you put all the solids onto the membrane.
Right, well that segues quite neatly into my next question, which is about what you think the challenges are for MBRs generally.
So, well, I think it's operability. How do you deliver the right amount of flow through the system in variable flow conditions? So it's the dynamics of operations of membranes, I think, hold them back. Clogging, of course, you taught me clogging was key. We live and breathe that here at Cranfield. But I think the dynamics, and I think it becomes really important in the anaerobic systems because they run at lower fluxes, and if I have to design those at full flow for treatment, it becomes ridiculous.
Right.
So I've got to be able to turn them up and down.
Okay, right, that's interesting because you don't often sort of hear about the hydraulic surges in anaerobic MBRs quite so much. Obviously it's a feature of full-scale works generally.
But there aren't many full-scale anaerobic MBRs, so on municipal treatment especially, so I don't think they've come to pass yet.
No, maybe not, but I guess you're right. It's interesting, isn't it? Because industrial MBRs, one thing you can control to some extent is the flow, but not necessarily the load, and that's where you see the anaerobic MBRs at the moment. It's for industrial, isn't it?
Yeah. For right. Especially the fat-laden waste.
Okay, so do you think anaerobic MBRs are one of those things that might come in the next 10 to 15 years? Or?
I think so. I think we're seeing a movement towards resource recovery, the circular economy. Anaerobic MBRs are pivotal in being able to deliver that. They generate the effluent quality that allows different tech post it for recovery, and they enable energy neutral sewage treatment. So you're never going to generate huge amounts, but you can run the works off grid effectively.
Right.
Without having to import sludge from other sites. So every sewage work could in principle go energy neutral.
A bold statement, Professor Jefferson.
Well, I thought that's the purpose here. Yeah.
We may as well. Yeah, let's go for it. Is there anything else you're planning to do in the future apart from anaerobic? Obviously, you must have an awful lot on your plate.
Yeah, we're still trying to push on the link to AOPs and photocatalytic reactors.
Oh, we're still on that one.
Yeah, so I think I still see those as quite important for recalcitrant removal. So if we can get that to work. It's a similar issue to all the other membrane systems. We've got to stop too much solids accumulation on the membrane to get them to work properly. So
a bit of a recurring theme in membranes.
Yeah. So that'd be the other big area in membranes, I guess, that I'm still really keen to push on. The rest of the team are doing work on algae and membranes.
All right. Okay.
And
so we're back to the circular economy again.
Yeah. So an interesting challenge, membrane and algae.
Imagine so.
Energy demands can be pretty high there, so how can we do it? So Mark Perdue is leading on that, so that should be really interesting. And then ceramic membranes seem to be popping up, so we're doing a bit of work on drinking water with ceramics.
Oh, marvellous.
So coag ceramics.
So basically, Bruce, there isn't anything that you're not doing at the moment,
well, no,
which somehow relates to
bits and
membranes.
pieces. Well, yeah. If we go broader into the team, obviously there's Ewan with all of his fancy dance membranes, reverse electrodialysis, and the rest. So yeah, but I'm still main flow. I guess that would be my distinction. I look to the main flow. Right.
Well, we're pretty much at the end of our time here. Just one last question. Is there any sort of firm ambitions you have for yourself specifically?
Oh, okay.
You mentioned your team and dutifully name-checked everyone. Is there anything you specifically would want for yourself in the next 5 to 10 years maybe? Apart from early retirement or some such.
I have to be honest. Again, this is going to be sound like a really cheesy answer, but I really want to see the anaerobic MBRs in practice. I think the resource recovery flow sheet, as you know, I've been about resource recovery and recycling ever since I've been at Cranfield actually, and so to actually see a sewage works delivering that, I think I want to see that before I retire. I've got a little while yet, so. But that would be the big hope. Well, a noble cause. Thank you very much indeed, Professor Bruce Jefferson. An absolute pleasure, Simon. Thank you. All the best. Cheers.